So far, we've been naming and writing formulas for binary ionic compounds, things with only 2 elements in them. Now we're ready to move to compounds that contain more than 2 elements. These compounds contain a polyatomic ion in there somewhere. Those polyatomic ions, remember, are made of 2 or more atoms, so when we put them together with an oppositely charged atom, we wind up with 3 or more elements in these compounds. To name these substances, there will always be at least one polyatomic ion in there. Those polyatomic ions are very easy to name because their names are on the back of the periodic table. So when you're doing one of these, you would just flip your periodic table over and find the correct name back there. Okay, let's practice writing formulas for these compounds. In these cases, we're going to start with the examples where you're given the name. So for example, I have potassium. The first thing I need to do is write the symbol for potassium. Potassium is the element abbreviated K, and I also need to know its charge. It's in group 1 and it has a positive 1 charge. Then I have sulfate. Notice how this ends in ATE. This doesn't end in IDE, which means it's not an element from the front of the periodic table, it's actually from the back of the periodic table. It's a polyatomic ion, so you have to kind of search around to find it, and you should find it as SO4 with a -2 charge. Go ahead and write your 2 ions, and now you're ready to do the crisscross. So I'm going to circle the charges and bring those down. This means that my K will have a number 2 after it. My sulfate is going to have a subscript of 1. Here's the trick with the polyatomic ions though. This 4 right here, this 4 was part of the formula for the polyatomic ion. Sulfate always has to have 4 oxygens. I'm not allowed to change that. In this example, I could put parentheses and put a 1 outside the parentheses. That would designate that there is 1 of everything inside the parentheses. So there's 1 SO4. In this example, you actually don't have to put the parentheses there because of the 1. You could just put K2SO4, which would mean the same thing here. Let me box my answer. Next we have magnesium hydroxide. Magnesium symbol is Mg, so I'll start with that. And the charge of magnesium is +2. It's in the second column of the periodic table. Now I have hydroxide. Hydroxide is one of our most commonly used polyatomic ions, and its formula is OH, and it has a -1 charge. To do my crisscross here, I would take the numbers and bring them down, and what do I get? I get Mg OH 2. Now there's a problem with the way I have this formula written. The way it's written right now, this 2 right here is only referring to the hydrogen, not the oxygen. What I really want is 2 of the whole hydroxide, not just the hydrogen. In order to show this, I am required to put parentheses around the OH with a 2 outside of it. This 2 on the outside means that there's 2 of everything inside the parentheses, the O and the H. So the correct formula here is Mg with parentheses OH 2. In the first example with the potassium sulfate, I didn't have to show the parentheses on that one because there was only 1 of the thing in the parentheses. On this one, because there's 2 of the thing in the parentheses, I have to show the parentheses so that the 2 refers to the whole ion. All right, and the last example on this slide uses ammonium. Ammonium is not a metal. Ammonium is a polyatomic ion found on the back of your periodic table. Its formula is NH4+. Of course, we know that plus is implied to be a +1. Sulfide, on the other hand, ends in IDE. This is not a polyatomic ion. This is just the element sulfur taken from the front of the periodic table with an IDE ending on it like we saw for nonmetal anions before. So this is sulfur. Can you find the charge for that? Sulfur would be a -2 charge so that it can gain 2 electrons to become stable. Now I'm ready to crisscross these numbers. And when I do that, I get NH4 with a 2. Now remember, if I want to show that I have 2 of the whole ammonium ion, I have to use parentheses. So I would have parentheses around the NH4 with a 2 outside of it, and then I have the sulfur. Sulfur had just a 1 coming down as the subscript. A 1 doesn't have to be shown in the formula, so I'm okay to leave it as NH4 parentheses 2S. If you want to show the 1 at the very end, you could, but it's not necessary. So this practice was going from a name to a formula. On the last slide here, we're going to go the opposite direction. Now you're given a formula and you're asked to write the name. Let's start with the first one. Li is the element lithium. Lithium is a metal, so its ending doesn't change. The question is, does it need a Roman numeral? Lithium, when I look on the periodic table, I see is in group 1. This means it always has a positive 1 charge, and it can never have any other charge. For that reason, it's a type 1 metal and does not need a Roman numeral. Then I go on to the non-metal part. Cn is 2 elements, so we have to look on the back of the periodic table. You find back there the name cyanide. Notice it already has an IDE ending. We don't have to change anything about that name. We just take it directly from the back of the periodic table. So lithium cyanide is your whole answer. That was easy, right? Next we have Sr parentheses H2PO4 2. Let's start with the easy part. Sr is the element strontium. Does strontium need a Roman numeral? Well, let's find strontium on the periodic table. Strontium is found in group 2. Because it's in group 2 of the periodic table, the only charge it can ever have is a +2 charge. It can never be anything else. For that reason, we do not need a Roman numeral. The H2PO4 part of this formula can be found on the back of your periodic table. This one has a long name. This one is called dihydrogen phosphate. This is because there are 2 hydrogens connected onto a phosphate. Phosphate is the name for the PO4. So the full name here actually has 3 words to it. Strontium dihydrogen phosphate. I should point out that I'm not using the word ion anymore because I don't have individually charged ions. I have compounds with 2 or more ions put together. And now for our last example. This has been a very long lesson, huh? This one uses Fe2SO4 Fe is the element iron, so I start by writing its name. When I look on the periodic table, I see that iron is a transition metal, and not one of the 4 special ones that we memorized as being part of group 1, or type 1, which means it's a type 2 metal. For type 2 metals, we are required to show the parentheses with the Roman numeral to indicate the charge of the iron. I'll come back to that at the end. First, let's get the name for the other easy part, which is SO4. SO4, found on the back of your periodic table, is called sulfate. This is one of the most common polyatomic ions we use. In this name, the last thing I need to fill in is the Roman numeral to show the charge. Remember, we can think of this as undoing the crisscross. The 2 on the iron came from the -2 charge of the sulfate, which matches what you see on your periodic table. The 3 right here came from the charge of the iron. That tells us that the iron had a +3 charge, and as a result, we use a Roman numeral 3 to show its charge in the name. There you have it, your final example.